Alright, today we're going to talk about part 4 of limits, and we're going to talk about undefined limits and indeterminate forms of limits. So we've already talked briefly about undefined limits, if you recall from the two-sided limits, or the piecewise when there's a gap. And today we're also going to talk about indeterminate, which means that when you plug in your a value, or the constant that x is approaching, you'll get a 0 over 0. So, for example, let's do undefined first. So, for example, if we have the limit as x approaches 3 of 5x take away 7 over x plus 3. And by x plus 3, I mean x take away 3. So when we take a look at this limit, we can automatically see that in the denominator, we are going to get 0. And in the numerator, we get 15 take away 7, which is 8. So 8 over 0 is undefined, which means that this limit does not exist. Similarly, if we had the limit as x approaches 3, negative 3, of 4x plus 7 over 3x plus 9, we would also get 0 in the denominator and negative 5 in the top. So we can say that this limit also does not exist. So when you get a 0 in the denominator only, it's similar to the error message on your calculator. There's no value that this graph approaches, so the limit does not exist. Now let's talk about indeterminate forms. So what this means is when we are evaluating by direct substitution, meaning we take a value and place it in, and we get 0 over 0. This limit is defined as an indeterminate limit. We have not determined anything from evaluating it. So an indeterminate form of a limit is when you evaluate it and get 0 over 0, which doesn't tell us any information. So we can't just say it equals 0, we have to manipulate it and figure out what it equals. So, for example, find the limit as x approaches 2 of x squared take away 4 over x take away 2. So if we were to plug in 2, we will get 4 take away 4 over 2 take away 2, which equals 0 over 0. You must show that it equals 0 over 0 and write indeterminate before moving on. So what we can do is we can say the limit as x approaches 2 of x squared take away 4 over x minus 2. Let's factor it, because in calculus and pre-calculus, factoring or the conjugate is usually a good way to manipulate algebraically. Make sure you write the limit in each step before you plug in the 2. So x minus 2 times x plus 2 over x take away 2. Now we can see that we can cancel a term from the top and bottom, and this equals the limit as x approaches 2 of x plus 2, and now that we can safely plug in 2, we get rid of the limit written notation, and we get equals 4. So originally we got 0, but the real limit is equal to 4. Now let's do an example where we have to deal with roots. So for example, find the limit as x approaches 1 of the square root of x, take away 1, over x minus 1. If we were just to plug in 1, we would get 0 over 0. So let's try a different strategy. Right away when you see a square root, you want to think the conjugate, because the only way to eliminate a square root is to multiply by the conjugate. And remember, the conjugate is this, the opposite sign in the middle of your term. So if we multiply by root x plus 1 over root x plus 1, remember this equals 1, we're not really changing the value, we will get the limit as x approaches 1 of root x times root x, which is x, root x times positive 1, and root x times negative 1 means the middle terms cancel, and we get negative 1 times positive 1, so negative 1. And on the bottom, let's not multiply, let's keep it as is, because I can see I could factor, or I could FOIL everything out, but if I leave the x minus 1, we can see that on the top we are going to be able to cancel. So when we simplify, we get the limit as x approaches 1 of 1 over square root x plus 1. Remember, we still have the value 1 in the top because it's still a fraction, and now we can evaluate. So we have 1 over the square root of 1 plus 1, which equals 1/2. So the limit as x approaches 1 of square root x minus 1 over x minus 1 is equal to 1/2. Finally, let's do another example. Let's do one with fractions. The limit as x approaches 3 of 1 over x take away 1 over 3 over x take away 3. Now this one looks terrifying because there's lots of fractions, but we do realize that if we plug in 3, we get 1/3 minus 1/3 over x, 3 minus 3. This does equal 0 over 0. So the first thing we're going to do, again, when we work with square roots, we'll use the conjugate. When we work with polynomials, we factor. When we're working with fractions, we want to get a common denominator. So let's go ahead and do that. So 3 and x need a common denominator of 3x. So I'm going to multiply this one by 3, and I'm going to multiply this one by x. And the second denominator is still the same. So again, we want a common denominator of 3x, so we multiply this one by 3, because that's missing a 3. We multiply this one by x, because it's missing an x, and we combine them on the top. If that's confusing, then please see your teacher. So the limit as x goes to 3, now that we have a double fraction, let's keep change flip. So we're going to keep the top fraction the same. We're going to change our second division to multiplication, and we're going to flip our bottom fraction. So instead of x minus 3 over 1, it'll be 1 over x minus 3. And now we can see that these two are almost the same, they're just opposites. So we cancel those, and because they're opposites, we're going to get negative 1. And so we have the limit as x approaches 3 of negative 1 over 3x, which would give us a value of negative 1 over 9 as our final answer. Okay. The only other example you might encounter with indeterminate forms is when we use function notation. If you remember back to grade 10, we talked a lot about f of x, f of h, f of q, etc. So let's do one with function notation. So if f of x equals 3x squared minus 2x plus 4, find the limit as x approaches 0 of f of x take away f of 0 over x. So we know what f of x is. We should probably find what f of 0 is. So first step is to find f of 0. So f of 0 is where we plug in 0 into everywhere we see an x. So 3 times 0 squared minus 2 times 0 plus 4, which equals 4. So now let's evaluate our limit. So we have the limit as x goes to 0 of 3x squared take away 2x plus 4. That's our f of x. Take away f of 0, which is 4, over x. So now let's simplify. So we have 3x squared minus 2x plus 4, except for the plus 4 and minus 4 cancel out. So we just have 3x squared minus 2x on the top and x on the bottom. If we were just to plug in 0 now, we'd still get 0 over 0. So let's do the limit as x approaches 0. Let's factor out an x on the top. So we get x, 3x minus 2. Cancel our x's. So we factored out an x from each term. X goes in front, and so we can say that the limit as x goes to 0 of 3x take away 2 is equal to negative 2.